Greetings and welcome, friends. This is a big day. This is a really big day for us. Previously, we've only been graphing lines by making like a table of values, plotting a whole bunch of points, and then drawing a line through it. Or when we had standard form, we graphed using the intercepts method, right, Jacob? Right, where we would plug in 0 for y to solve for x, that was the x-intercept, and we'd plug in 0 for x and solve for y, that was the y-intercept. It's still like a lot of work. It was kind of a lot of work to do all that, and then you'd plot those points and you'd draw the line. Today, I'm going to teach you to be more tactful in your approach of graphing lines. Today, we are going to graph using Slope-Intercept Form. That's right, this thing's going to evolve like Pokemon here. Look out. It's like an anamorph. I don't know any anamorph references. But Slope-Intercept Form is going to be mighty powerful. Here we go. My mic just fell. That was crazy. That was a mic drop moment right there. At least a mic rotate moment. So here we go. We've got Slope-Intercept Form. A linear equation written in the form y equals mx plus b is in sloppy intercept form. The slope of the line is m. Hey, we've heard that before. M, that's the same rise over run, right? That's the same rise over run. That's the m that we would get if I do y2 minus y1 over x2 minus x1. That's the same m, okay? And the y-intercept of the line is b. So the effective thing here is once I have an equation in this form, I can simply look at it. Would you look at it? Look at it? Man, look at that. Would you look at it, though? That's amazing. And just looking at the number in front of x, I know that's going to be my slope, and the constant, the number being added to my variable term, is going to be my y-intercept. And so notice I would be able to graph this by plotting wherever my y-intercept is. It's going to cross at 0, b. And then I can move by my slope, right? Whatever that is from there. So down and over, or up and over, right? And Mario runs to the right. And so slope and y-intercept when it comes to lines, all right? Because there are infinitely many different types of lines, right? Jacob's looking that up on his phone right now. There are infinitely many different types of lines on the coordinate plane, right? They're all over the place. However, I like to think about your slope and your y-intercept as being the DNA of a given line. All right? If I know the slope and the y-intercept, I can define, I can graph, I can picture the distinct line that has that DNA. There's only one line that will ever have that slope and that y-intercept. Okay? And then later on in this chapter, we'll talk about slopes that are like related, or lines that are related where maybe they have half of their DNA similar to each other. We'll talk about that later on. But today is a big day, friends. So here we go. So here's my slope-intercept form, y equals mx plus b. Notice that the y-intercept is right here, is this point where it crosses the y-axis. And here we go. This, I can move by my slope. So, right, if I want to go up 1 over 1, notice my slope, 1 divided by 1 is 1, etc. And so every line that I can imagine, other than vertical lines, can be written in the form y equals mx plus b, and all I need to know is the y-intercept and the slope, and I can then define that entire line. It's a wonderful thing. So let's see if we can put this to work. It says identify the slope and the y-intercept. So looking at this question, let's see, what is the slope? Nope. M is equal to 3. And what is the intercept? Good call, is -4. That minus sign goes with it. I like that. Right? It's like plus a -4. Right? Plus a -4. And then we'll figure out our slope in a minute. So if I want to graph this, we're going to start here, and we're going to move by our slope. Or actually, even better yet, we're going to begin at the B, and we're going to move by the M, friends. So we begin, right? B, man, that's so clever. It's like, that's the cleverest. So let's see. Let's plot the point at -4 y-intercept. So that's right here. And then I'm going to move by my slope. So my slope is 3. So I'm going to go where? Wait a minute, 3. Don't I need a run? What's the run, son? I like that. Yeah, 3/1, friend. So I can move up 3 and over 1. Because that was the beginning. Yeah. And guys, 2 points. Yeah, I could graph a line through just 2 points. But let's find a couple more just for fun. Up 3 and over 1. Up 3 and over 1. And so those will be some points on my line. And now I can draw my line. So let's see. So I'll line it up at 1 there. And the further points away from each other that I pick, the straighter my line will be. It'll be less likely I have an error over the long run. And so look at, I've just drawn infinitely many points that make this equation true with just a couple little facts. It's because I knew its DNA. I could predict where it was going to be and when. Yeah, look out for that. So let's see. So this was my purple graph. Okay, here we go. Part B. Y equals 6.5. What's the slope? Well, let's write it in y equals mx plus b, right? So y equals 0x plus 6.5. Well done with the catch that the slope is 0. Yeah. And the intercept? Positive 6.5 there. Not bad, not bad. All right. So let's begin at 6.5. So here's 6, here's 7. Where's 6.5? In the middle of 6 and 7. And, all right, and here we go. From 6.5, I'm going to go up 0 over what? Over 1. So up 0 over 1. Up 0 over 1. Up 0 over 1. Guys, what's that line look like? That's a horizontal line, friend. Here we go. Horizontal line. Thing of beauty. So there's my blue line. Y equals 6.5. Horizontal line. So yeah, so for this, right, I just want to point out, right, there was our last line. Y equals 3x minus 4. For this equation, it's actually going to yell at me. It won't let me do 6.5 there, will it? Nah, but it's going to be horizontal. I have this program to skip. All right, part C. What is the slope? No. No. Now the problem, friends, is this equation is not in slope-intercept form. I don't know its DNA. You just sent an innocent man to jail. I've got to write this as y equals mx plus b. Yeah, good. Yeah. I don't know. So guys, what I need to do is solve for y. Let's talk about our old school skills of solving for a variable in terms of other variables. How do I get y by itself? No, it's got this like negative 5x there. It's got this minus sign in front of it. Add 5x. We want to get everything away from y. I'll add 5x to both sides. Now, Jake, you'll notice that I wrote plus 5x underneath this negative 2, but they're not like terms. I just know that I want to put it in front of the constant, because notice that the mx is in front of the constant in slope-intercept form. So I'm kind of like pre-planning that, friend. So I'm going to have the opposite of y equals 5x minus 2. How do I get rid of that minus 1? I could just multiply everybody by -1 or divide everybody by -1, or you just say, let's just opposite everything. Either of those strategies are fine. So I'm going to have y equals -5x plus 2. So here is my equation in slope-intercept form. And actually, those of you who said the slope was -5, you were technically right. But I knew you were wrong for concluding it in that case. It was a false positive, as they say. So what's my slope? Now that it's in slope-intercept form, mx plus b. What's the m? -5. And what's the b? +2. So let's graph this. All right, so where do I begin? Where do I begin? With the b. So let's start at 2 on the y-axis for the y-intercept. And I'm going to move by my slope, -5. What's the run on this slope here? It's down 5 for the rise, over 1, okay? So from this point, down 5, 1, 2, 3, 4, 5. My graphs are overlapping here, my apologies. Over 1. And let's do it again. 1, 2, 3, 4, 5. Over 1. And let me plot some points there. I'll make this an orange graph. Why not? Orange, you glad I didn't say banana? Burnt orange is my favorite color, by the way. It's true. I don't know. Spectrum? Yeah, so all of them then. Yeah. So guys, So guys, the y-intercept was 2, right? And the slope was -5 over 1. And so notice my equation, y equals -5x plus 2, right? Same, right? And my slope doesn't have to be whole numbers. It could have been down 5 over 2 and have been a fraction, or down 3 over 2, right? Things like that. But the equation is always just y equals mx plus b. And you will be able to recognize these right out the gate just looking at the equation. Let's have you guys try 6, 7, 8 on the monitoring progress. Find the slope and, oh dear, y-intercept of those problems. So let's try these. I'll be around to help. Slope, y-intercept. Bunch of information out. Very similar to last. I'm looking for M and B. Get it, the B on the graph, and then watch me move by my slope. Right, focus here, guys. Like we're practicing. Compare it to your example 3. Remember, you can compare it to your previous example. Mario, run. Sometimes. Like that. Like that. Actually, you can still get your graph open by graphing it down there. Like, black and without you. Begin at 1. I did it. Y-intercept. That's the tricky one. Yeah, number 8 is tricky. It's going to be similar to this one. You're going to have to evolve that one first. You're going to mega evolve standard form into slope-intercept form by solving for y. Oh, yo. All right, over here to convert this into slope-intercept form, I would subtract x from both sides. You are correct in saying those are not like terms, but I'm going to squeeze that in front right there. 4y equals negative x minus 10. Ooh, I like this problem. How do I get rid of that 4? Divide everybody by 4. And Trinley, watch out for this one. This one's tricky. Instead of leaving this as negative x fourths, which is true, I'm going to rewrite that. Imagine a little positive 1 in front of that. I'm going to rewrite that as negative 1/4 and then an x on the side. Okay? Because I want that slope to be really apparent to me. If I didn't do that, it's kind of weird. I wouldn't really know what the slope thing was going on there. And then negative 10/4, that's the same as negative 5/2. Or, side note, that's the same as negative 5/2 is equal to negative 2.5. This one's tricky. This one's annoying to graph because of the decimals on it. But let's graph this first one here. Begin at 1. Move by my slope. I'm going down 6 and over where? Over 1, because I could always write that fraction as over 1 if it's not already a fraction. And Mario runs to the right. And then down 6 and over 1. All right, so this line, and the line, by the way, exists not just for the points that I plotted, but it exists forever in both directions. So don't just connect your dots, like extend the line beyond your dots and draw some arrows at the end of it. Okay? All right. So here's question 6's graph. All right, I saw some good work on this one. Slope was 0, and the y-intercept was 8. That's just a horizontal line. You could think about it as going up 0 over 1, up 0 over 1, up 0 over 1, but I don't even think we need to think that far. We can just know. You guys just know that that's a horizontal line. Right? So there's numero 7. Okay, this one's tricky, friends. So what was my slope here for number 8? -1/4. And my y-intercept? -5/2. -2.5. Yeah, it might be easier to think about that. So to graph this, here we go. I'm going to go down 2.5. Right? And my slope is -1/4. How do I move? Depending on how you think about it. We always do rise over run. I'm going to go down 1. So -2.5 minus 1 is going to give me -3.5. And then what's my run? 4. All right, so down 1 over 4. So I'm at -3.5 height. Let's move by the slope again. Down 1. Down 1. Now I'm at -4.5. And where do I move over? Over 4. Mario runs to the right when it's positive like that, right? Denominator positive is usually the easier way to do it. Right? And then let's draw that line. Like so, like so. And I've represented infinitely many solutions to that equation without having to do infinitely many steps or much work, right? That's not bad. That's not that much cheese. So there's number 8 was the orange graph. So slope-intercept form is way better than the other forms. Yeah. It's just way better. Let's look at example 4, last example, and then we'll do some marble slides. So, all right, example 4. Now, wait, let's make sure. I don't think anyone but you or maybe one other person are looking at this just yet. So, why can't I just, like, steal the slope and y-intercept right now, though? Right, I've got to put it in slope-intercept form. I've got to mega evolve this Charizard, okay? We got to do it. We got to evolve this thing. So, to get the y by itself, why am I trying to get y by itself and not x by itself? Man, seriously, go check out Jake Math on YouTube. He'll help you out. Yeah, he's going to get all my views. He just said we're solving for y and not x because the equation is y equals mx plus b. The y is by itself. Man, seriously, Jake Math, it's amazing. Y equals -2x plus 2. Okay. All right. Which brave soul, show of hands, could tell me the slope? The slope is -2. I agree. Jacob, you with us? You agree too? Yeah? Yeah, I understand. It was like a process. So there's -2 is my slope. Someone else, except my competition, Jake Math on YouTube, because I mean, come on. I've already done a shout out. Little promo, a little plug. Yeah, my y-intercept is 2. Isn't that great? You can just like look at the equation, right? We just look at the equation, and then I immediately know the slope and y-intercept, right? I can just look at this and know it's DNA and instantly imagine in my head infinitely many points that make that equation true. Because I know y-intercept is 2, slope is -2, down 2 over 1, down 2 over 1, down 2 over 1. Draw that, right? It's amazing. So let's graph this. Begin at the B. Begin at the B. Oh, wrong color. All right. So there's my y-intercept of 2. And I'm going to move by my slope. How do I move? How do I know it's over 1? All right, if it's a whole number, I can just throw a 1 on that, right? Or an integer, I guess that's technically an integer. Down 2 over 1, let's plot that point. And do it again, down 2 over 1, plot that point. Down 2 over 1, plot that point. And I believe I mentioned to my students in class that negative 2 over 1 is the same as positive 2 over negative 1. So if I wanted some points in the other direction, I could also have gone up 2 and backwards 1, right? Backwards 1 and get a point on the line. Up 2 and backwards 1. And that would be useful, perhaps, like if my y-intercept was way over here and my next point was going to be over here, and I'd be like, oh no, it's going to go off my graph. But I could have accomplished the same thing by moving this way, perhaps, okay? So that's why you might want to know that backwards trick. So let's draw this line. Here we go. Yeah, I gave myself a few extra points, and I'm going to line up my points that are furthest away from each other for the most accurate line. Look at that. All right. We're not done yet. We've got the y-intercept. We've got the slope. They wanted me to figure out what is the x-intercept here. Oh, is it because that was the number in front of the y? So, no. Is that because this L looks like a 1? No, that's not why. It's because that's where my line crosses the x-axis. So the x-intercept is 1, 0. You can also, that's the coordinate of the x-intercept. You could also just say x-intercept is 1 if you wanted. All right? I think we're good for today, internet friends. I hope you enjoyed this amazing experience. Let's actually graph y equals negative 2x plus 2 using my awesome grapher. So that was the slope, y-intercept of 2, and the slope was down 2 over 1. Look, that's the same line we just had, and there's that equation. Thing of beauty. Thing of beauty. Well, we appreciate you, internet friends. Remember to go check out Jake Math on YouTube. Bye-bye.